Hi, this is the course about validation, and this is the second module of part 2 where we discuss the topic of validation in general and how it fits into domain-driven design. In this module, we will see how to combine the Fluent validation library with the value object design pattern, such that we enjoy the benefits of both of them. We will also talk about the final building block that forms the good validation technique. So far, we've discussed the definition of validation and the two building blocks that will help us deduce good validation techniques. Let's quickly reiterate. The validation itself is the process of mapping a set onto its subset. The first, larger set is the set of elements the external world operates. It's unrestricted by anything. The second, smaller set represents the possible states of our domain classes. It is restricted by invariants, the conditions that define our domain model. The first building block we discussed in the previous module is the concept of always valid domain model. When modeling the domain, we need to operate sets that closely align with the sets of the underlying domain concepts and not include invalid states in those sets. In other words, we should not allow our domain objects to become invalid. That goes against the whole practice of strong typing. The second building block is that all validation rules belong to the domain layer. That's because these rules are the same thing as invariants, and as I already mentioned, invariants define our domain model. We use validation rules to differentiate valid and invalid domain objects. So where exactly should we keep our validation rules then? Right now, the validation rules related to emails and student names are duplicated. If we look at the register request validator, you can see that we have a rule checking that the email should not be empty, its length should not exceed 150 characters, and that it should conform to basic regular expression. And we can also see the same validation rules in the email value object: non-empty requirement, maximum length, and the regular expression check. Moreover, our controller invokes both of these sets of rules. First, the Fluent validator is invoked by ASP.NET before executing the controller method. And then the controller method invokes those rules again when instantiating the email value object. So how to overcome this issue? We cannot keep the validation rules in the Fluent validator class, because those rules should belong to the domain layer. But at the same time, if we use the approach with value objects, we lose all the benefits of the Fluent validation library, namely the declarativeness of the validation checks and the fact that ASP.NET automatically invokes those validation checks for us. Can we somehow combine the benefits of both approaches while having the drawbacks of none of them? Yes, we can. We can keep our validation rules in value objects and at the same time have the validator class use those value objects. Let's see how this can be done. We can use the custom validation rules we discussed in part 1 of this course to implement rules on top of our value objects. Here you can see we use this custom rule to check the number of elements in a collection. We can introduce a similar rule that would check that a primitive type is a value object. I will restrict this custom rule to strings for now. Later we will be able to add an overload for, say, integers if we need one. The second argument here is the factory method that converts a string into a value object. Here's how we can implement the rule itself. If the string is null or empty, then we just return and don't do any validations. Here is the factory method itself. If the result is a failure, then we need to add that failure to the context, similarly to how we did it in the other custom validation rule, except that here we take the error message from the result class. Finally, we also need to cast the return value to this interface. Now we can use it in the validator. The email should not be empty, and it must be a value object. The type of the value object is decided by the factory method that we pass as an argument. And of course, we also need to add the condition here. Very good. We can also simplify this expression by removing the explicit argument. This notation is a little bit shorter. And before we test this new feature, we need to fix a couple of compilation errors left from our previous refactoring. Since we cannot create our value objects using their constructors anymore, we need to use the factory methods in our fake repository. Alright, let's run the application, making the email invalid, sending it, and you can see that our new custom validation rule works. It correctly shows the error with the email field. And if I change the email back, then the student is registered successfully. Let's do the same change with the student name real quick. Now in the controller, we don't need to validate the email and the student name value objects anymore. We can create them without validation, which simplifies our controller logic. In the previous demo, we combined the Fluent validation library with value objects by introducing a custom validation rule that tries to convert a string into an email instance and, if the conversion is not successful, transforms the error from the result object into a Fluent validation failure. This way, we are getting the benefits of both approaches, without their respective drawbacks. On the one hand, we keep the validation rules in the domain layer, in the value objects, but on the other, we are still using the Fluent validation library to invoke those validation rules, and thus don't clutter our controller with the validation checks. Of course, we're still creating the value object instances in the controller, but that's just one line per each value object instance. Notice how we are calling .value on the result instance returned by the create method. This .value call is unsafe because it throws an exception when the result instance is unsuccessful. But since we know that Fluent Validator has already invoked the create method prior to entering the controller, we can safely do this .value call. If the create method was unsuccessful, we wouldn't even get into the controller. ASP.NET would have returned an error by that time already. Also notice that such a use of exceptions does not contradict what we discussed in the previous module, that validations should return an error and not throw exceptions. Our validation code in the Fluent Validator does rely on return values. Here the exception acts as a failsafe, a sanity check. Its activation means a bug in our system. It means that we have not set up the validation properly and have missed one of the validation checks. The difference is that we don't catch exceptions thrown by the .value call. We allow it to propagate and fail the whole operation. This is called the fail fast principle. This principle sacrifices the experience of one user who receives this application error in order to prevent the potentially corrupted application state from being persisted in the database, where it would be much harder to deal with. Finally, notice how we moved the validation logic to the domain classes without having to make those domain classes invalid first. We're still adhering to the both building blocks of the good validation technique. Before moving on to the next topic, let me fix one thing here. We don't actually need this check for emptiness, so I'm removing it. That's because in the create factory method, we already check for email non-emptiness. Alright, so these are the two versions of our email validation rules. The first original one created using Fluent validation rules, and the second one that uses our value object. These two versions look and behave similarly, but not exactly the same. Can you spot the change that we introduced when we moved the validation logic from the Fluent validator to the email value object? Again, here are the old rules, and these are the new rules. Take a moment to notice the difference and feel free to pause the video. I'll wait a couple seconds. Ready? Okay. The difference is this trimming operation. We didn't have it in the original version of our validation rules. If you remember, when we worked with the request data at the beginning of this course, we passed that data without transformation to the student domain class. We only did validation, but we didn't actually trim the incoming email or student name. And so if the client would send us any data with trailing or leading white spaces, we would have saved it as is. We would have to manually do the trimming before using these values. There is another quite popular way to do validation. Here you can see the create method both validates the input string and returns an email instance if that string is valid. What we could do instead is we could introduce a validate method that would only do the validation, but not the instantiation of the email instance. In order to instantiate the email, we could make its constructor public and do the same validation here just for the sanity check, so that the client code would not be able to create the email without validating it first. Now in the controller, we can do something like this. Validate the email, and of course this logic would go to the Fluent Validator class. I'm just showing it here for brevity. And then instantiate the email and pass it to the student. This approach with separating the validation process in two steps, validation and instantiation, looks reasonable at first, but it has a major flaw. You might have noticed that I have introduced a bug here. We are checking the length of the email string after trimming it, but then we are assigning that string without the trimming. So we could still create an invalid email object here. For example, if the input string would have 200 trailing spaces. And that despite the fact that we are calling the validate method to protect against invalid states. To avoid this issue, we would have to trim the value in the email constructor as well, and therefore duplicate our validation rules.